Right now we're standing here at our new FOL linear drive laser machine with fiber technology. This is already the second generation of the fastest laser machine in the world. So what we are showing here especially is to cut different kind of materials one after the other without any setup at the machine. So what's interesting here is the incredible cutting speed we can reach. We can cut specially non-ferrous metals, which are quite difficult to cut on a CO2 laser machine. So coming back to the speed of the machine, what we are showing here right now is aluminum cutting of 0.8 millimeter thickness, and we cut speeds up to 100 meters per minute. What we have realized already in thinner aluminum, let's say about 0.5 millimeter thickness, we were able to reach cutting speed of about 150 meters per minute. So this is up to 6, 7, 8 times faster compared to conventional laser systems. So what makes this machine so special? Actually, we have an active medium which is a fiber laser source. This fiber laser source has 1/10 of the wavelength of the CO2 laser. So how is it generated? I told you the active medium is a fiber. This is stimulated by laser diodes. We have a certain number of laser diodes stimulating these fibers. They are combined together, and we have a certain number of modules that enables a laser power of, in this case, 4 kilowatt. If we just require 2 kilowatt, we just use 4 of these modules. So the reason why we choose the shorter wavelengths is that we have a real huge benefit in cutting these non-ferrous metals. The absorption of the laser beam into the material is much better with this shorter wavelengths. And this is the reason why we are able to cut those materials and of course to cut them that fast. So the other hand is expanding the product ranges. So we are able to cut copper, brass, titanium, which is important to some of our customers and actually not possible to do on a CO2 laser. And this is in a symbiosis with a linear drive laser machine that is possible to have access speeds up to 340 meters per minute. So the theoretical maximum cutting speed value we can reach could be up to 240 per minute. The controller already can do it. The linear drive can do it, so it's just to find the right cutting parameters. Of course, this is a kind of benchmark. If it's realistic to use this in practical use day by day, this will be so fast that you need a certain number of people to pick up the parts afterwards, but it's just showing what is possible with this machine. So we're continuously working on developing new cutting parameters and improve cutting speeds and qualities. So fiber laser may not replace the actual CO2 lasers, but it's a really good add-on to the CO2 lasers. We can produce parts that are right now not possible to cut with the CO2 laser. We can do it much faster. So it's just a question what the customer wants us to do.